This PowerPoint covers Pythagoras, trigonometry and bearings that you've probably met in previous years. You might find that you only need to scan through this very quickly, or you might need to practice some of the questions listed at the end of the thing. Each slide will have my explanations, and the following slide usually has the good copy, so you can copy the notes into your notebook. So proceed, and also I'll be putting some demonstrations of the use of the calculator along the way. Okay, here we are talking about Pythagoras. So if I have a right angled triangle, well, the right angle's moved up a little bit. If we label the three sides, we label this side A, this side B, and this side C. Pythagoras theorem says that A squared plus B squared equals C squared. You'll have to excuse the handwriting. I've got to use a mouse to do this, and it's not that easy. Okay, so Pythagoras theorem states that A squared plus B squared equals C squared. C is called the hypotenuse. It's opposite the right angle. It's the longest side of the triangle. This works for any right angled triangle. Like I've said in the previous slide, on the next slide you'll see a typed copy of all this, a nice neat copy, so you can wait till then to copy down the notes properly. Alright, so there's Pythagoras theorem. So when we look at part 2 here, it says use the Pythagoras to work out the missing lengths, showing your workings in the space below. So on this triangle here, here's my right angle. So W is my hypotenuse. So we start off with, say, W squared is equal to the hypotenuse squared. So just writing that way around is equal to 4 squared plus 3 squared. It's plus. So before we work out W, we need to work out square the numbers. So this becomes 16. 4 squared means 4 times 4. And 3 squared means 3 times 3, which is 9. And therefore W squared is equal to 25. 16 plus 9 makes 25. So W will be equal to the square root of 25. And we know the square root of 25 is equal to 5. Alright, that's the first one. Second one, once again, where's the right angle? There's the right angle. So x in this case is the hypotenuse again, so I'm going to get x squared is equal to 9 squared plus 5 squared. So x squared is equal to 81 plus 25 is 106. So x is equal to the square root of 106. That would be the exact answer. 106 is a third, so that would be the exact answer. But if we went to our calculator, we'd find approximately this would be equal to 10.30. Okay, so those first two examples is where the hypotenuse was the unknown. The next two examples we'll find that it's one of the other two sides, one of the shorter sides. So here's the right angle triangle. This is the hypotenuse. So that y here is one of the shorter sides, and so is 8. So this is the hypotenuse here. So we'd be writing y squared plus 8 squared is equal to 10 squared, the hypotenuse squared. So that gives me y squared plus 64 is equal to 100. So y squared, if we take 64 from both sides, we get 36. And we take the square root of both sides here, we get y is equal to 6. Alright, we go to the fourth example here. There's our right angle, so 12 is the hypotenuse. So here I would say z squared. Now the shortcut you can start if you're finding a short side, the square of the short side is going to be equal to the hypotenuse squared minus the other short side squared. Always the biggest number will go first. So this gives me z squared is equal to 144 take 81 makes 144 take 81 is 63. So z is equal to square root of 63, which is approximately 7.9. Something or other. I haven't got the answer in front of me at the moment. Okay, if you proceed to the next slide, you'll see a nice copy of this, but that's the explanation. Here's the third part of the Pythagoras problems, is finding the length between two points on the Cartesian grid. So we've got to find the length of this line here, so let's call this x. And the secret to this is to actually form a right angle triangle by dropping a vertical line down from that point there and then a horizontal line across there. So here's my right angle triangle. Once again, remember the next slide has a nice neat diagram to this. We work out the length of this line here, so it's going from 1 up to 4, so the length of this line is 3. This is going from 1 through to 6, so the length of this line is 5. So now we can use Pythagoras' theorem. X is once again is the hypotenuse because it's opposite the right angle. So we can say x squared is going to be equal to 3 squared plus 5 squared. That is a plus sign there. Let's make it look a bit better, marginally better. That's squared there. Alright, so x squared is going to be equal to 9 plus 25, which is 34. And x is equal to the square root of 34. And as I'll show in a moment on the calculator, that's approximately 5.83. If the question asks for decimal places, then you give the answer to the number of decimal places given. If it doesn't ask for decimal places, then the exact value, the third value, is the answer we should be giving. Okay, the next thing we'll look at how to use our calculators correctly here. Okay, I'm now going to show you how we use our calculator to do some of these things and getting our calculator settings right for this topic. Okay, so the first thing, we're here on the home page. If we actually go to our settings, number 5 over here, and go to document settings, for this topic we'll leave our display digits as float, or we'll change that to float 6. The angle needs to be in degrees, so use the arrow key, go down there and make sure you select degrees. I think you'll find the calculation mode for this topic, it's best to make it auto and leave the CAS mode on. There's no other settings we need to change there. So float 6, degree, and calculation mode on auto. So when you get to the bottom here, go OK. Alright, we'll start a new document. Do I want to save my last one? I'll say no. I'm going to add a calculator page. So in our previous question there, one of our things was to do the square root of 106. So I need to go Control X squared button because the blue writing's the square root. Type 106. If I just press enter, it gives me the third form. If I want the decimal answer, I need to go Control Enter. Now, this has given my answer to 6 decimal places because I asked for a floating decimal with 6 figures. So you can see there's 10 places there. There is a command on your calculator called the round command. You can go round, just type it, and then go up and select that number and say how many decimal places you want to round it to. And I'm going to say I want to round this to 2, and it'll tell me, well, it's only given me to 1 decimal place. That's not what I expected. It's 10.30, I think, is where it's rounded off. So we'll do another one in a minute. So one of the other ones we had before was the square root of 63, sorry. And I'll go Control Enter. And if I rounded this to 2 decimal places, so go round, go up and select that number and go comma 2. You notice the calculator has stored all the decimal places it can for that number, and it gives me the answer 7.94. There is an interesting way of using the calculator for these problems. We could use the solve command. Go to menu, go to algebra and select solve. And if I type Pythagoras' theorem, so for the fourth example we did there was the one with z, 9 and 12, I could write 12 squared is equal to z squared plus 9 squared, and I want to solve for z. And it tells me the answer here is 3 root 7 or negative 3 root 7. Now, when you take a square root, you actually get a positive and a negative answer, but for Pythagoras we're dealing with length, we're only dealing with the positive answer. If I went Control Enter, oh, sorry, I need to be down there. If I go Control Enter, I'll get the answer there as approximating 7.94, just like we got up here. Alright, so that's how we can use our calculator for Pythagoras problems.